Have you ever stopped to wonder what would happen if the Earth's core suddenly just stopped spinning? It might sound like something straight out of a sci-fi thriller, but the reality is, this scenario would spark some truly mind-boggling consequences for our planet. The Earth's core, a fiery, dense ball of iron and nickel, lies about 3,000 kilometers beneath our feet. And it's not just sitting there. This colossal spinning sphere is a powerhouse, driving the magnetic field that shields us from dangerous solar radiation and helping to keep our atmosphere in balance. But what if that spin came to a screeching halt? The answers might surprise you. Now, imagine if this vital engine of our planet came to a halt. What would that mean for life as we know it? In this video, we'll dive deep into the implications of such an extreme scientific scenario. We'll explore how the cessation of the core's rotation could disrupt the magnetic field, leading to potential consequences like increased radiation exposure and climate shifts. But it's not just about the science. It's about the ripple effects on our daily lives. How would technology, navigation, and even our health be impacted? This thought-provoking topic invites you to consider the delicate balance that sustains our existence on Earth. So, buckle up as we embark on this intriguing journey into the unknown. Together, we'll unravel the mysteries of our planet's core and discover the profound significance of its relentless spin. Get ready to challenge your understanding of Earth and its inner workings in ways you never thought possible. Understanding the Earth's core. The Earth's core is a fascinating and complex part of our planet, consisting of two distinct layers: the inner core and the outer core. The inner core is a solid sphere, made primarily of iron and nickel, with temperatures reaching up to 5,700 degrees Celsius. Despite these extreme conditions, the immense pressure keeps it in a solid state. Surrounding the inner core is the outer core, a fluid layer composed of molten iron and nickel. This liquid state allows for the movement of materials, which is crucial for the generation of the Earth's magnetic field. The core plays a significant role in influencing geological activity. The convection currents in the outer core create a dynamo effect, which generates the magnetic field that envelops our planet. This magnetic field is essential for protecting the Earth from solar winds and cosmic radiation, acting as a shield that maintains the stability of our atmosphere. Without this protective barrier, life on Earth would face severe challenges. Moreover, the core's dynamics also contribute to tectonic activity. The heat from the inner core drives convection currents in the mantle, leading to the movement of tectonic plates. This movement is responsible for earthquakes, volcanic eruptions, and the formation of mountain ranges. In summary, the Earth's core is not just a distant, hidden part of our planet. It is a vital component that influences geological processes and maintains the magnetic field essential for life. Understanding its structure and function helps us appreciate the intricate systems that sustain our world. The mechanics of spinning. The Earth's core is not just a static mass. It is a dynamic entity that spins at remarkable speeds. This rotation is governed by the principle of angular momentum, which is the quantity of rotation of an object and is dependent on its mass, shape, and speed. Angular momentum is crucial because it helps maintain the stability of the Earth's rotation as a whole. The core's spinning creates a balance of forces that contributes to the overall dynamics of our planet. As the core rotates, it generates a magnetic field through the movement of molten iron in the outer core. This magnetic field is vital for protecting the Earth from solar radiation and maintaining the atmosphere. The rotation of the core also influences the planet's stability by contributing to the overall rotational inertia of the Earth. This inertia helps keep the planet's axis tilted at a consistent angle, which is essential for the stability of our climate and seasons. Now, imagine what would happen if the core's spin were to suddenly stop. The disruption of angular momentum would lead to a cascade of effects. Without the core's rotation, the magnetic field could weaken or even collapse, exposing the Earth to harmful solar winds. Additionally, the stability provided by the core's dynamics would be compromised, potentially leading to shifts in tectonic activity and climate patterns. In essence, the mechanics of the Earth's core spinning are fundamental to the balance and stability of our planet. Understanding these dynamics allows us to appreciate the intricate forces that sustain life on Earth. Immediate consequences. If the Earth's core were to stop spinning suddenly, the immediate effects would be profound and far-reaching. One of the most significant changes would occur in the magnetic field. The core's rotation is essential for generating this field through the dynamo effect. If the core ceased to spin, the magnetic field could weaken or even collapse entirely. This would expose the Earth to increased levels of solar radiation, potentially disrupting communication systems, satellite operations, and even power grids. The implications for life on Earth could be severe, as the protective shield that the magnetic field provides would be compromised. In addition to changes in the magnetic field, seismic activity would likely be affected. The core's movement influences convection currents in the mantle, which play a crucial role in tectonic plate dynamics. A sudden halt in the core's rotation could lead to unpredictable shifts in these currents, potentially triggering earthquakes and volcanic eruptions. The stability of tectonic plates would be thrown into disarray, leading to a surge in geological activity that could reshape landscapes and impact ecosystems. Moreover, the Earth's rotation itself would be impacted. The core's spin contributes to the overall rotational inertia of the planet. If the core stopped, the balance of forces that dictate the length of a day could be disrupted. This might result in changes to day length, potentially making days longer or shorter, which would have cascading effects on climate, weather patterns, and biological rhythms. In summary, the immediate consequences of a sudden halt in the Earth's core spinning would be dramatic, affecting everything from our magnetic field to seismic activity and the very rhythm of our days. Long-term effects. If the Earth's core were to remain stationary, the long-term consequences for life on Earth would be significant and potentially catastrophic. One of the most pressing issues would be the alteration of the magnetic field. A weakened or collapsed magnetic field would expose the planet to increased solar radiation, leading to dramatic climate changes. Without the protective barrier that the magnetic field provides, the atmosphere could thin over time, resulting in harsher weather patterns, increased temperatures, and more extreme environmental conditions. These changes would disrupt established climate systems, affecting agriculture and water resources globally. The impact on ecosystems and biodiversity would also be profound. Many species rely on stable environmental conditions for survival, and significant shifts in climate could lead to habitat loss and increased extinction rates. As ecosystems struggle to adapt to new conditions, food chains could be disrupted, leading to cascading effects throughout the biosphere. Species that cannot adapt quickly enough may face extinction, while others may thrive, leading to a shift in biodiversity that could alter ecosystems irreversibly. Human civilization would also face immense challenges in this new reality. As climate patterns shift and resources become scarce, societies may struggle to adapt. Agriculture would be particularly vulnerable, as changing weather patterns could lead to crop failures and food shortages. Communities might be forced to migrate in search of more hospitable environments, leading to potential conflicts over resources. In summary, if the Earth's core remained stationary, the long-term effects would reshape life on our planet, challenging ecosystems, biodiversity, and human civilization in ways we can only begin to imagine. The resilience of life would be tested, and adaptation would be crucial for survival. Scientific theories and speculations. The idea of a non-spinning Earth core has intrigued geophysicists and scientists alike, leading to various theories about its implications. One prominent theory suggests that if the core were to stop spinning, the resulting changes in the magnetic field could lead to a phenomenon known as geomagnetic reversal. This is when the magnetic poles switch places, which has occurred multiple times throughout Earth's history. While this process typically takes thousands of years, a sudden halt could accelerate the timeline, leading to unpredictable consequences for life on Earth. Another theory posits that a stationary core would disrupt the convection currents in the outer core, which are responsible for generating the magnetic field. This disruption could lead to a complete collapse of the magnetic field, exposing the planet to harmful cosmic radiation. Geophysicists speculate that this exposure could result in increased rates of skin cancer and other health issues, as well as significant impacts on technology reliant on satellite communications and navigation systems. Speculative scenarios also arise from our current understanding of Earth's geology and climate systems. For instance, the loss of a stable magnetic field could lead to drastic climate changes, affecting weather patterns and potentially triggering mass extinctions. However, it is essential to recognize the limits of our knowledge in this area. While scientific theories provide valuable insights, they are often based on models and assumptions that may not fully capture the complexities of Earth's systems. Encouraging critical thinking about these theories allows us to appreciate the uncertainties and challenges that lie ahead in understanding our planet's intricate dynamics. As we explore these possibilities, we remain reminded of the vastness of what we have yet to learn. Conclusion. In this video, we've journeyed through the fascinating world of the Earth's core and its critical role in sustaining life on our planet. We explored how the core's spinning generates the magnetic field that protects us from harmful solar radiation and maintains the stability of our atmosphere. The dynamics of this spinning core are essential for geological activity, influencing everything from tectonic movements to climate patterns. We also examined the immediate and long-term consequences of a hypothetical scenario where the core suddenly stops spinning. In the short term, we discussed the potential weakening of the magnetic field, increased seismic activity, and disruptions to the Earth's rotation and day length. Over the long term, the implications could be even more severe, leading to drastic climate changes, loss of biodiversity, and significant challenges for human civilization as we adapt to a rapidly changing environment. As we wrap up, it's clear that the Earth's core is not just a distant, hidden part of our planet. It is a vital component that influences many aspects of life as we know it. Understanding these dynamics encourages us to think critically about our planet's future and the delicate balance that sustains it. If you found this exploration intriguing, we invite you to engage with our content further. Don't forget to subscribe to our channel for more thought-provoking discussions. Like this video if you enjoyed it, and explore our related content to deepen your understanding of Earth's mysteries. Your curiosity fuels our journey together, and we look forward to sharing more insights with you.